The tickets are already sold. SpaceX has been taking deposits for Mars since 2016. NASA has a target date. Governments have signed agreements. Rockets are being tested. Volunteers have applied by the hundreds of thousands, ordinary people, not astronauts, who want to be among the first humans to stand on another planet. Nobody told them what the scientists actually know. Not the official version, not the press releases, the data. The studies that sit in peer-reviewed journals, written by NASA's own researchers, that use phrases like, may significantly increase mortality estimates, and right at the edge of what is considered acceptable, and 100% of conjunction-class astronauts will develop osteopenia. The research that says, in language careful enough to be publishable and honest enough to be alarming, that the human body was not designed for what we are about to ask it to do. This is that story. Earth is wrapped in a magnetic field, the magnetosphere, that deflects most of the high-energy particles streaming from the Sun and from supernova explosions across the galaxy. It is invisible. Most people never think about it. It has been protecting biological life on this planet for billions of years, quietly absorbing the kind of radiation that, without it, would have stripped Earth's atmosphere and sterilized the surface long before the first cells evolved. The moment a spacecraft leaves Earth orbit, that protection ends. Mars is 54 million kilometers away at closest approach. A crewed mission would take approximately 7 to 9 months of transit in each direction, plus time on the surface 2 to 3 years total by most planning estimates. For every one of those days, the crew would be exposed to galactic cosmic rays, high-energy particles originating from supernova explosions elsewhere in the galaxy, traveling at nearly the speed of light, capable of penetrating any shielding material humans have ever built. NASA has a radiation limit for astronauts. It is set at a 3% risk of death from radiation-induced cancer over a career. A Mars mission, according to NASA's own modeling, delivers a central risk estimate of 5% radiation-induced mortality, with an upper 95% confidence interval approaching 20%. 20%, 1 in 5, from radiation alone, before accounting for anything else that could go wrong. The lead researcher at Colorado State University, who reviewed these numbers, described cancer risk from galactic cosmic radiation as a potential showstopper for a crewed Mars mission. Not a complication, not a risk to be managed, a reason not to go. There is no adequate solution. Shielding heavy enough to stop galactic cosmic rays would make a spacecraft too heavy to launch. The materials scientists are testing hydrogen-rich polymers, liquid hydrogen walls, advanced composites, reduce exposure, but do not eliminate it. And solar particle events, bursts of radiation from solar storms, can push doses to nearly lethal levels within hours, with warning times measured in minutes. The people planning to go to Mars know this number. They are going anyway. In microgravity, the human skeleton stops doing the job it evolved to do. Bone exists because of mechanical stress, the constant compression of standing, walking, running, fighting gravity. Remove the gravity, and the body reads the absence of stress as a signal that bone mass is no longer needed. It begins reabsorbing calcium at a rate of roughly 1 to 1.5% per month from weight-bearing bones. 1 to 1.5% per month. For a 2-year mission, that compounds. A study published in a peer-reviewed journal and using NASA mission data predicted that 62% of astronauts on a shorter Mars trajectory would develop osteopenia, the stage before osteoporosis, where bone density has fallen to dangerous levels. For astronauts on the longer trajectory, the one required to reach Mars at certain points in its orbital cycle, the number is 100%. 100% of astronauts on a long Mars mission will develop clinically significant bone density loss. A fracture on Mars is not the same as a fracture on Earth. There are no emergency rooms on the Martian surface. There is no evacuation possible once you have landed. A broken hip 250 million kilometers from the nearest surgical team is a death sentence with a delayed timeline. Exercises help. Resistance training during the mission slows the loss. It does not stop it. The body is in a continuous negotiation with the absence of gravity, and over a long enough timeline, gravity wins. The brain changes too. In studies of astronauts returning from long-duration missions aboard the International Space Station, researchers found structural changes in the brain shifts in the position of white matter, alterations to the ventricles, movement of cerebrospinal fluid into spaces where it does not normally accumulate in such quantities. The fluid that cushions and protects the brain, freed from the normal downward pull of gravity, redistributes. It presses upward. The optic nerve, which carries visual information from the eye to the brain, runs through this pressure zone. Roughly 40% of astronauts on long-duration missions develop measurable changes to their vision. Some develop what looks like the beginning of elevated intracranial pressure, a condition on Earth associated with serious neurological events. The condition has a name now: spaceflight-associated neuroocular syndrome, SANS. Scientists do not fully understand why it happens. They know it happens. They know it gets worse with duration. They know that some astronauts return from 6-month missions with permanent visual changes that do not fully resolve. A Mars mission is 3 times longer than a 6-month ISS rotation. In November 2024, research published in the journal Futurism documented measurable cognitive slowdown in astronauts returning from long missions, processing speed, reaction time, memory consolidation, all measurably reduced. The researchers noted that missions to deep space, far longer and far more radiation intense than anything the ISS involves, may change the situation significantly. No one has been in deep space for 2 years and come back for scientists to measure. The Apollo astronauts who went to the moon spent at most 12 days beyond Earth's magnetosphere. The Mars crew will spend over 700. Then there is the silence. Not the silence of space, the communication delay. At minimum distance, a radio signal from Mars to Earth takes roughly 3 minutes. At maximum distance, 24 minutes. For a mission that spans years, the crew will spend months operating at communication delays of 20 minutes or more in each direction. A message sent in the morning will not receive a reply until evening. An emergency call for help will not reach Earth in time for any response to be useful. In October 2015, a crew member aboard the ISS developed a deep vein thrombosis, a blood clot in an internal jugular vein during a mission. The crew had access to an ultrasound machine, but no one aboard was trained to interpret vascular ultrasound results. They called Earth. Specialists talked them through the imaging in real time. A treatment plan was relayed. The situation was managed. The communication happened in real time because the ISS is only a few hundred miles up. The signal, round trip, takes less than a second. On Mars, that same call takes 20 minutes to arrive. The answer takes 20 minutes to return. A blood clot, a burst appendix, a cardiac event, a severe bone fracture from a fall in the lower but not zero Martian gravity. Any medical emergency that on Earth is resolved in an operating room within hours becomes, on Mars, a 40-minute problem before help can even respond. The crew would have to diagnose, decide, and begin treatment before any expert voice could weigh in. They would act, transmit what they had done, and wait 40 minutes to hear whether it was right. In a cardiac arrest, brain damage from oxygen deprivation begins in 4 to 6 minutes. The 40-minute communication window is not a delay, it is a wall. The crew going to Mars will be trained in emergency medicine. They will carry surgical tools, medications, diagnostic equipment. They will be, by the time they launch, among the most medically capable non-physicians in human history. And they will still be alone. NASA's own risk documentation uses a specific phrase for situations like these: austere environments where medical evacuation is not possible. They have known this since the first mission designs were drawn up. It is in the planning documents, it is in the risk assessments. It has been accepted as a condition of the mission, not solved, not mitigated away, accepted because there is no other option. You cannot put a hospital on Mars before the people who need it arrive. The human mind was not designed for this either. A crew of 4 to 6 people, sealed into a volume roughly equivalent to a 2-bedroom apartment. No private space, no fresh air, no natural light cycles, no ability to go outside in any meaningful sense for the duration of the transit, rotating through the same hours, the same faces, the same walls, for 8 months before they even arrive. Studies of Antarctic winter-over crews, the closest analog we have for the isolation involved, found that by the midpoint of a long isolated mission, conflict rates increase, cognitive performance declines, and something researchers call the third quarter phenomenon emerges. A measurable dip in morale and psychological function that tends to peak approximately 3/4 of the way through a long confinement. The third quarter of a Mars transit mission falls somewhere over the outer asteroid belt, 200 million kilometers from the nearest human being outside the capsule. In simulated Mars missions conducted on Earth-sealed habitats where crews live in isolation for months at a time, forbidden from going outside, communicating with the outside world only through delayed messages, researchers have documented something that the participants themselves did not always predict. After the initial excitement fades and the novelty dissolves into routine, a specific psychological weight settles in. Not depression necessarily, not breakdown, something harder to name. The accumulated awareness that the walls are the same walls as yesterday, that the faces are the same faces, that the menu cycles and the schedule cycles and the distance between you and the nearest tree or open sky or stranger's voice only increases. One participant in a simulated 520-day Mars mission described the experience of the final months as existing in a kind of permanent present. Not bored, not suffering, just present. With no arrival approaching quickly enough to feel real, the actual mission will be longer. In deep space, with radiation accumulating, with bones slowly thinning, with the brain fluid pressing in directions. Evolution never anticipated, and the crew will know, with precise mathematical certainty, exactly how far they are from home. The onboard computer will display it. The communication delay will remind them, every morning when they wake up, every night before they sleep, the number will be there. Not an abstraction, a fact, updated in real time, growing. None of this is unknown. None of it is classified. Every number in this script comes from published research, some of it authored by NASA itself. The risk assessments are public record. The scientists who ran the studies gave interviews about their findings. The journals that published them are freely accessible. The SpaceX website still takes deposits for Mars. There is a version of this reality where that is a scandal, where someone should have told people, where the gap between the public story, mankind's next great adventure, the multi-planetary future, humanity's destiny among the stars, and the private data represents a failure of honesty. But the data is not hidden. It is just not in the promotional material. And the people who are actually going, not the people who bought deposits on optimism, but the trained astronauts and mission specialists who have read every study and attended every briefing and understand what the numbers actually mean, those people are going anyway. What this says about them does not have a clean scientific framework. Every ship that ever sailed into unknown water knew it might not come back. Every expedition that ever crossed a continent without maps accepted that the maps might be wrong about what lived there. Every person who has ever walked towards something genuinely dangerous, knowing it was dangerous, and kept walking, they were not operating on certainty. They were not operating on ignorance either. They were operating on something that sits between those two things and has no precise name. The awareness that the danger is real, the acceptance of it, and the decision to go forward, not because the risk has been resolved, but because the thing on the other side of the risk matters enough. The first humans who leave for Mars will carry all of this with them: the cancer estimates, the bone studies, the SANS documentation, the psychological profiles from 520-day isolation simulations. They will know, with more precision than any explorer in history has ever known, exactly what the odds look like. They will pack that knowledge alongside the food and the medical equipment and the communication arrays and the radiation dosimeters that will count every day how much of their career limit they have consumed. And then the trajectory will commit. The physics will take over. And the only direction will be forward. The tickets are already sold. The Mars missions will launch. The first crew will strap in, watch Earth shrink behind them, and enter a silence that no human being has ever sustained for this long. They will exercise to slow the bone loss. They will wear dosimeters. They will follow the protocols. They will talk to each other and to Earth and to whoever is listening on a 40-minute delay. And somewhere in the outer belt, in the third quarter, when the distance meter reads a number so large, it stops feeling like geography and starts feeling like something else. They will look at each other in a capsule the size of a two-bedroom apartment, with the data they already know sitting in their heads, and they will keep going, because they always knew it was going to be like this. They read the papers. They signed up anyway. Thanks for watching, and I'll see you in the next one.